What is an electron?
An electron particle is a complete circuit. Electrons flow. An electric current is a flow of electric charges. With electric charges flow in the opposite direction. When another bulb is added to the circuit, more electric charges flow. The basic electric charge is a particle called the electron.
I can't see any electrons.
They're far too small to be seen.
If you can't see them, how do you know they exist?
You can't see the wind, but that's no reason to believe that the wind doesn't exist. You can't see the wind, but you certainly can see things the wind does. What's making this wheel spin? The wind? No, there's no wind blowing inside this glass tube. The wind is turning this wheel. The wind hits against the windmill and makes it turn. Electrons are hitting against the blades of this wheel, making it turn. If we disconnect the power supply that makes the electrons move, the wheel stops turning. Electrons flow away from here. As they move through the tube, they hit against the blades of the wheel. You can't see the electrons, but you can see the effect they have on the wheel. The electrons that hit against the wheel and make it turn must have mass. When an object has mass, it can move other objects by colliding with them. If this wrecking ball didn't have mass, it couldn't exert a force to smash against the wall. If electrons didn't have mass, they couldn't make the wheel turn. This and many other experiments. In order to balance this small weight, you'd have to put this many electrons on the other pan of the balance. Every material there is made up of tiny particles called atoms. This liquid is called copper sulfate. It's partly made up of atoms of copper. These two metal strips are platinum. The copper sulfate has no effect on the platinum strips. Now there is a complete circuit. The battery is acting as a pump, pushing electrons. The bubbling suggests that something is happening inside here. And it was. The right-hand strip of platinum is now covered with a thin layer of copper. the bubbles are on the other side. And now copper atoms are on the left-hand strip of platinum. It's as if electrons were connected to the copper atoms, because when electrons flow in this circuit, copper atoms move too. And in fact, we believe today that all atoms are partly made up of electrons. Balloons are made of atoms. Electrons are connected to atoms. So there are electrons on the two balloons. There are also electrons on the silk scarf. When the balloon is rubbed with a silk scarf, electrons are actually rubbed off the silk onto the balloon. So the silk has a shortage of electrons, and the balloons have extra electrons. Any object that has a shortage of electrons, or any object that has extra electrons, is said to have an electric charge. The two balloons each have extra electrons. That means they both have the same kind of charge. When two objects have the same kind of charge, they repel each other. That means that they push away from each other. We're rubbing electrons off the scarf onto the hanger. Now the hanger has extra electrons. The balloons also have extra electrons, so the balloons and the hanger all have the same kind of charge. Objects with the same kind of charge repel each other. The scarf has a shortage of electrons. Objects with different kinds of charges attract each other. The hairbrush doesn't attract or repel the banana. But what if we could rub some electrons off the cat onto the brush? We can even attract a stream of water. There seem to be electrons in all these materials at least. Electrons are being forced off here and made to travel in a narrow stream down this tube. The other end of the tube is coated with fluorescent paint. Where the stream of electrons hits it, it glows. Apparently, the hanger and the stream of electrons have the same kind of charge because they repel each other. If the stream of electrons inside the tube could be repelled and attracted fast enough and in just the right directions, we could make a picture as complicated as this.
Tomorrow, mostly fair in the west and south portions.
A television picture is made by a stream of electrons that hit against a screen coated with fluorescent paint. If you look through a magnifying glass, you can easily see the lines made by the stream of electrons as it is moved back and forth across the screen at a very high speed.
These cattle have just arrived from ranches in the west.
The electric charges that make the stream of electrons move in the proper way to form a picture are controlled by these electron tubes. Electron tubes act like valves or faucets. They can turn a flow of electrons on and off. They act very quickly. These tubes can turn a flow of electrons on and off 1,000,000 times a second. These are transistors. Transistors can do what electron tubes do, although they do it in a different way. Transistors have the advantage of being very small. The fact that electrons are easy to control makes them an extremely useful move in such complicated machinery as this. This is an electronic computer. The turning wheels are not the important moving parts of the computer. The important moving parts are the electrons themselves moving in the circuits of the machine. Electronic computers are used in science and industry to solve complicated mathematical problems. Let's try this one out on an easy problem. For example, adding this column of numbers together. The column of numbers is written in code on these cards with holes punched in them. It took the electronic computer about 1/1,000,000th of a second to add those numbers together. We haven't proven to you that there are such things as electrons. You haven't seen one, and the effects you have seen could have been caused by something else. But the fact remains that there are many things in the world today that wouldn't exist if there weren't some kind of tiny particle that has mass and that carries an electric charge.